So what are you guys?
We're part of the Swartwood family.
Hey guys, we had a request to do a GRE problem. Basically, somebody wanted something along the lines of applying analytic geometry or maybe just regular geometry. So I figured, why don't we do a problem that incorporates both, okay? So this is something you really could see on the GRE. And it's kind of a classic sort of problem, but not an absolutely standard problem. So let's go ahead and give this guy a shot. So I'm going to set up this way. So quantitative comparison, just to remind you of what this is like. It's like, is column A bigger? Is column B bigger? Are they the same, or can you not tell? Okay? And what's the setup here? We're going to put our axis right here. All right. So let's set our axes up here, coordinate axes. And let's say we have a guy at 0, 3 and 3, 0. Okay? And then we have a line connecting the two. All right. And now, so what's the actual question? So they pick some arbitrary point here. Let's say x, y. Okay? And then the question for you is, column A is x plus y. Okay? And then column B is 2.9. Okay. All right, no big deal. So let's give this a try and see. Give yourself a second, try this out, and then we'll talk shop. All right, so again, maybe not your absolute standard problem, but one you could definitely see. So let's take a look at this guy. I think there are different ways to do this. One is, let's try analytic geometry. Okay, so if I'm trying analytic geometry, that means like, equations of lines, things like that. We can go for the equation of this line, right? So for the equation of the line, I'll do it this way. Y is equal to mx plus b. Okay, no big deal. And then you remember this guy, the slope? To get that slope, right, we have to basically look at rise over run. All right, so the change in the y guy over the change in the x guy will give you the slope. And it doesn't matter which one you subtract. So you could do, for example, like, I don't know, for the y's, 3 minus 0 or 0 minus 3. It doesn't matter as long as you're consistent. Okay, so I'm going to go this guy minus that guy. Okay, so for the change in y's, we're going to have 3 minus 0, right? And then over here, we're going to have 0 minus 3. 0 minus 3. And that's going to be 3 over minus 3 or minus 1. Okay, so it's going to be negative 1. Okay, not too bad. So for this equation, you get y is equal to negative 1, right? Okay, so y is equal to negative 1x plus blank. Okay, to get that b, we plug in any point, right? Just jogging your memory here. So I'm going to try that. I'm going to plug in this point. So the y coordinate is 3, right? The input is negative, okay, 0 here, and then plus b. So b is equal to 3, okay? Of course, if you remember the meaning of b right here, b is basically the intercept. So if you look at the y-intercept, it's where you cross the y-axis, and you definitely cross it at 3. So the answer is going to be 3 anyway. Okay, no big deal. All right, so then our equation is going to be y is equal to negative x plus 3. Pretty rote. Looking at this, so of course, there's shortcuts. Like you can see the intercept here is 3. You can also see the slope here is going to be negative 1, because first it's negative, it's pointing down. And then it's 1 because if you move over from 0 to 3, you also drop down from 3 to 0. Okay? But whatever, we can just crank it out like this. It's not that bad. Now, one thing I want to point out here, which is generally good for all quantitative comparison problems, is go for what they give you. So what I mean is, before you sit down and just start cranking through this sucker, because if I were cranking through this, well, you try to solve this, you look for some quantity like this, you try to figure out something with x, then plug it in and get the value, et cetera, et cetera. Nothing wrong with that, but it's not efficient for problems like this. So since the quantity you're comparing is this sum, right? Don't go for the pieces, go for the sum. So once we're bother looking at each individually, we're going to look for this sum. So what I'm going to do is we're going to add to both sides and get x plus y, right? Adding to the left and to the right. Because now what you got is this guy is 3, this guy is 2.9. Clearly 3 is bigger, so A actually wins. Column A wins. Okay? Right. But I did say that this problem is kind of double duty, because we did this with analytic geometry, but it's nice because you can actually do this with just regular old geometry. Okay? So let's give this a try. I'll do this again. And again, the point here is not to just get the answer. It's to talk about how you can work on technique for other problems. So one major technique here, sometimes for these quantitative comparison guys, we're actually going for the entire thing. So don't go for a piece and try to put the pieces together. If you can, go for the entire thing all at once. Okay? All right, so let's try this again. Same thing, same problem. But we want to do this with old school geometry. So if you're doing old school geometry and you look at this guy, I think it's something like this. There's your x coordinate. Okay? So I think it's something like this. This length here is 3, and this length here is 3, right? and you know you have a right triangle. So this is actually an isosceles right triangle. So you know it's a 45, 45, 90 right triangle, or an isosceles right triangle. Okay, so that tells me this angle here is 45, and this angle here is 45, right? But it actually makes it really nice, because when you look at this, so let's look at this line right here. This triangle is also a right triangle, right? And since this is 90, and this is 45, and this thing has to add up to 180. Well, 180 minus 90 is 90. So the sum of these two other angles must be 90. Well, this is 45, so this too is 45, right? Some of the angles of the triangle go to 180. This guy's 90, so 180 minus 90 is 90. So this plus this must add up to 90. 45 plus a mystery angle must add up to 90, right? So when you solve for this mystery angle, subtracting 45 from both sides, this guy is 45, okay? Likewise, same argument. If you look at this right over here, and this guy, this is 45, this is 90, this too must be 45, okay? So then you're kind of like, well, big whoops, so what? What that means is this is an isosceles triangle, right? So whatever this length is, it's the same as this length. I should use different colored chalk. And then same thing for this guy. Whatever this length is, it's the same as that length, right? But you know the total distance from left to right is 3, or up and down. It doesn't matter which way you want to do it. So I'm going to walk left to right. So the total distance from left to right is 3. That means this length right here, right, plus this length right here is 3, right? Okay, but what is this length? This guy corresponds to this coordinate, right? Okay, but what about this? Well, this guy, left to right, is the same as up and down. But this up and down corresponds to your y coordinate. Does everybody see that? So what you really have here is this and this, right? But that's the same as this. So what you've got is this sum right here is going to be this guy plus that guy. But it's clear, you're just walking from here to there, so it's got to be 3. Okay? So this too is 3. Well, obviously we already knew it was 3, just another way of doing it. Again, so what is the idea? Take a look at this guy, look at what they're asking you. Again, we'll try to go for the entire sum. That's the inspiration, because you want to go from here, x plus y, right? So you want both of these guys. What are the relationships in there? Well, you've got isosceles triangles. So this and this are the same, and this are the same. But now the nice part is, since you want this and this sum right here, right? Since this guy is equal to that guy, it's just left to right plus left to right, and that gives you 3. I'm not worried about these particular problems per se, even though you might see problems like this on the exam. What I'm more worried about is picking up these techniques, these ideas, okay? Quantitative comparison, you look for the entire quantity, not just for a piece of that quantity. And that holds true for many different problems, okay? All right, so hopefully that helped. Just let us know and we'll try to do more of these videos.